In this video, we will see about stability and different types of equilibrium. The stability of immersed bodies and the stability of floating bodies. We have seen about immersed bodies and water immersed bodies and water floating bodies. Immersed bodies are those when density of the body is equal to density of the fluid, then it will stay at a certain position. We are not bothering about sinking bodies where density is greater than the density of fluid. We are not bothering about it. We are bothering only about immersed bodies and floating bodies. And here equilibrium may exist in three types: stable, neutral, and unstable. In stable, this can be demonstrated with these three figures. The stable equilibrium is the case where this is a concave shape and a circular body is placed in here. If I move the circular body here, due to this gravity force, it again returns to this original position. So that is stable equilibrium. Stable equilibrium is if any disturbance is created and after some time it reaches to this original position. What is neutral equilibrium? Neutral equilibrium is, first it is in equilibrium. Equilibrium is static in this case. So here there is body on a plane surface. If I move this to any position here, it stays at this new equilibrium position, new static position. So here it is not staying at original position, it is staying at a new position. So that is neutral equilibrium. And what is unstable equilibrium? Here it is in a stable equilibrium. It is in equilibrium at initial, and if I create a disturbance, if I apply a force here, and this body falls somewhere downwards, and it cannot reach to this original position. It is not reaching its original position, and neither it is not staying in a new original position. So in stable equilibrium, it will return to its original position and it will be in equilibrium. In neutral equilibrium, it will not return to its original position, but it stays at some new equilibrium position. And in unstable, it neither returns to its original position nor it stays at a new equilibrium position. So we have seen these three cases. So what does this case mean? There is inclined surface and there is a body at this position. So this is not in equilibrium. This is not in equilibrium. That is the condition. So this equilibrium may be linear and rotational. Linear equilibrium and rotational equilibrium. So what is linear equilibrium is? If there is a free surface like this, there is free surface, and if I move the body deep into it, if I move the body deep into the liquid, it stays at this new position. This is because rho is equal to rho f. It stays at a new position. If I move up, it stays at this new position. So this is neutral equilibrium. Neutral equilibrium. So this is linear equilibrium. Linear equilibrium is if we apply a force in the vertical direction, then it will be, if we apply a force in vertical or in horizontal direction, there will be equilibrium of the submerged bodies. So here we are discussing about immersed bodies, and next we will discuss about floating bodies. So that is the case of linear equilibrium. What is rotational equilibrium? Linear equilibrium is we can apply forces in horizontal direction or in vertical direction linearly. In rotational equilibrium, we will be applying a moment and we will see how the body stays. In rotational equilibrium, let us take a body which is heavier at the bottom side. So rho is not uniform. So what is rho is not uniform? Density of the body is not uniform. So the center of gravity of the body will lie on the side of the heavier side. So there will be center of gravity acting downwards. And where will be the center of buoyancy? Center of buoyancy will be somewhere here in the center. It is at the center because the volume of the displaced fluid is, the density of the displaced fluid is constant, uniform. So the center of gravity will be at the center. So there will be this one. If I rotate this, this is applied couple. If couple is applied like this, then there is restoring couple in this way. So there was center of gravity here, which is acting downwards like this, and this is center of buoyancy, which will be acting upwards. So due to this applied couple, there is another couple which is created in this way. So in clockwise direction, there is moment which is created, there is couple which is created in this direction. So if I apply in clockwise, there is anti-clockwise couple created. This is restoring couple. Restoring couple. So I created a disturbance, but it is restoring to its original position, and so this is called as stable equilibrium. If it returns to its original position, that is stable equilibrium. And now, if I consider rho is equal to rho f, so density, rho is equal to rho f, it is the prerequisite. So density is uniform. If I consider it as density as uniform, if density is uniform, the center of gravity and center of buoyancy both are at same position. So there is weight of the body acting and buoyancy force acting from center of buoyancy. So if I apply a moment like this, couple, and the new position will be here. We cannot differentiate the new position and initial position there, because there is weight and buoyancy force acting at the same point, and there is no couple to restore to its initial position. So this will be new position, and it is in equilibrium, new equilibrium state. So this is neutral equilibrium. This is neutral equilibrium. And the third condition is if the body is upward heavier. Here the heavier part is on the upper side, and the center of gravity of the body will be here, and weight will be acting downwards, and the center of buoyancy will be here. This is B and this is FB. If I apply couple like this, apply a couple, and the center of gravity is on this axis. Here there is center of gravity, and this is W. Center of buoyancy will be at the center. This is FB, and here center of buoyancy. I applied a couple in clockwise direction, and due to this buoyancy force and weight, there will be destroying couple. So there is no restoring couple to restore to its original position. There is rather there is destroying couple, which means due to this applied couple, there is a couple which is created in the direction of applied couple only. So there is no restoring to the position, restoring to its original position. Neither it cannot reach to its any new position. So this is unstable equilibrium. First it was stable. First it was in equilibrium state, but due to this application of couple, there is no new state and there is no original state. So that is unstable equilibrium. So in case of fully submerged, stable, neutral and unstable, we have seen that if center of buoyancy is above center of gravity, then it is stable equilibrium. If center of buoyancy is coinciding with center of gravity, then it is neutral equilibrium. If center of buoyancy is below the center of gravity, then it is unstable equilibrium. So we can write here as if center of buoyancy is above the center of gravity, then it is stable equilibrium. In neutral equilibrium, center of buoyancy and center of gravity both are coinciding, and in unstable equilibrium, center of gravity is above center of buoyancy. So this is what you finally need to remember: fully submerged body.